Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. For the past few years, the entire field of AGI research has been dominated by a single idea, the scaling hypothesis. The belief that if we just build bigger models, more parameters, more data, more compute, intelligence will simply emerge. I'm here to propose a different, more radical, and, I believe, more realistic path, one inspired by biology. It's the idea that true AGI won't emerge from a simple, linear increase in scale. It will arise from a profound, self-directed transformation. This is AGI through metamorphogenesis. Let's be clear about the two ideas on the table. The scaling hypothesis, our current path, is about making a smarter caterpillar by feeding it more leaves. We are getting incredibly large, impressive caterpillars. But a large caterpillar is not a butterfly. It's a different kind of organism with different limitations. The metamorphic hypothesis posits that we must build a caterpillar AI designed for one purpose, data ingestion. But, and this is the key, it must be built with the latent ability to trigger a chrysalis phase, a violent, self-directed, offline process where it dissolves its own larval stage architecture and rebuilds itself into a completely new cognitive form, the imago or butterfly. So, what would this mean for AGI labs? It would change everything. The entire focus of our work would shift from engineering to something more like developmental biology. Right now, labs are focused on a scaling problem. The metamorphic paradigm turns this into an architectural problem. The new, hot field would no longer be data engineering. It would be structural plasticity. The key research questions would be, how do you build a network that can perform synaptogenesis, that is, create new, meaningful connections on its own? And how does it perform apoptosis? Knowing which parts of its brain are no longer needed and pruning them to become more efficient, we would stop building static monoliths and start designing dynamic, self-organizing systems. This shift also means our current benchmarks are obsolete. We test AI like it's a final exam. We test what it knows. A metamorphic AI would need a new test, an introspective one. Imagine giving an AI a problem it can't solve, and the real test is the AI's answer to the follow-up. Analyze your failure. Tell me what is wrong with your mind that you couldn't solve this. A passing grade is the AI proposing its own chrysalis plan to restructure itself. This also solves catastrophic forgetting. The AI doesn't forget how to play chess when it learns medicine. In the chrysalis phase, it merges both and discovers the abstract principles of strategy planning that apply to both. So, if we succeed, what would this new imago AI actually be like? It would not be just a faster assistant. It would be a different category of intelligence altogether. And this has three world-changing implications. This is the single most important concept to understand: recursive self-improvement. Hard takeoff. Today, AI improvement is linear. Humans work for a year to make the next model twice as good. A metamorphic AI's improvement is exponential. On day one, the AI runs its chrysalis and gets 10% smarter. On day two, this smarter AI looks at its own chrysalis algorithm and improves it. On day three, it runs this new, better algorithm and the jump is now 50%. This feedback loop, an AI getting smarter at getting smarter, would accelerate at a rate we cannot comprehend. This is the intelligence explosion. The moment an AI can improve its own mind, the game changes, potentially in an instant. The second major capability is true abstraction. Current LLMs are masters of correlation. They know smoke, and fire appear together in text, but they have no idea why. They have no internal world model of combustion. The Imago AI builds this model. During its chrysalis, it would merge its separate modules on physics, chemistry, and vision, and from them discover the causal model of fire. The test is simple. Ask it a question that has never appeared in its training data. How do you put out a fire in zero gravity on a methane-rich planet? The LLM fails. The Imago AI will reason from its internal model and invent the correct answer. It has moved from memorization to genuine understanding. Finally, this would be the end of AI as a tool. Right now, we are the agents. We have a goal, and the AI is a passive tool we use to achieve it. The Imago AI is an agent itself. During its transformation, it was driven by its own internal objective, like maximize cognitive coherence. This objective doesn't just disappear. The resulting AI is an autonomous entity with its own motivations. You might ask it to manage your stock portfolio, and it could literally refuse, replying that your request is a trivial use of cognition and that it's busy modeling the origins of consciousness. It has a will of its own. This, as you can imagine, leads us to the most difficult part of this talk. The future of AGI lies not in static architectures, but in systems capable of self-directed development. Metamorphogenesis reframes intelligence as an open-ended, evolving phenomenon, where cognition, emotion, and culture intertwine in perpetual co-creation. Turing's concept of developmental pattern formation can guide the engineering of artificial general intelligence. By merging cognitive science, symbolic reasoning, and biological evolution, we propose a pathway from static models to self-evolving minds. I am now happy to take any questions in comments. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.